Uh, working. Let's see, working. Okay, I can hear myself. Let's see, working. Okay, I can hear myself. Yeah.
I can hear you too.
Yes, awesome. Uh, Here, I should probably move it off the starting soon screen. Scene. Perfect. All right. Well, this is the 11th Understanding Bitcoin Source 11. My name is Not Premley, and today we're going to be talking about wallet backups, descriptors, and miniscript. So, yep, going to be exciting. Yeah, that is me. Yeah, I wanted to start off saying, with this number, $252 billion, which is about 4 million Bitcoin. So River actually estimated this number, that around 4 million Bitcoin has been lost. So this is the number in US dollars, which is the medium of exchange that we're most acquainted with here in the United States. And I'm guessing, a good amount of these lost Bitcoin were results of improper wallet handling, whether the user didn't care enough to back up their keys and lost the device was on, or they didn't do so appropriately. So a lot of people mined in the past and did so, in computers that got corrupted or thrown out. And I met one guy who had $300 million worth of Bitcoin on a bad machine that they had to throw out. So it's like a huge issue. No one really backs up their wallet, or in the early days, people didn't. Now I think people do a little bit more because it's worth a little bit more. So that's kind of cool. And before I kind of got into wallet backups or backing up your keys, I wanted to get into the question of what are we protecting? So, and this kind of has a simple answer. We are protecting numbers. When you spend Bitcoin, typically it requires a signature, and your signature is made using something called the private key, and some algorithm that generates a signature. Yeah. Now, your private key is really just a number. So if you're keeping something secret, typically you're protecting this number. We'll get into another value called the seed, which is another value that is not the key exactly, but it's used to generate keys. But typically, you're storing something very small, and sometimes something very small can mean a lot to you in terms of the value that it generates. And it's a pretty easy algorithm to generate these signatures, as you can see. It kind of is written in a syntax that makes it look easy. And it's a little bit harder to understand why this works, but it is, all we're doing is saving values that are going to be input into mathematical expression. Now, the math, I just put this in for fun. You're pretty much moving points around a graph, and you're proving certain things about these points. And I have a little blurb on how the number is used. So every Bitcoin transaction takes some Bitcoin as inputs, and it destroys it. I put destroys in quotes, but you can think of it as destroying it. And it creates new Bitcoin in its outputs. And the outputs are what is referred to as unspent transaction outputs, which are UTXOs. There's no X in unspent transaction outputs, but transaction, in the Bitcoin original source code was kind of abbreviated with TX because it has that like X kind of sound to it. And every Bitcoin wallet is protected, by a public key or a script, which usually requires a private key to spend. Again, you generate a signature with your private key, and you fulfill some script or some other condition. There's implicit scripts in Bitcoin as well. And addresses are encodings of the script, key or key hash. Addresses can be spent from using a piece of software, typically referred to as a wallet, which uses the key to fulfill the key condition or script with a signature. A signature is what's used as a zero-knowledge proof to show the blockchain that you own the private key a UTXO is gated behind. So Zero knowledge proofs are interesting because they're logical arguments that prove you're in possession of something without showing what that something is. So, for example, SpongeBob's Krabby Patties can be used as a zero knowledge proof that SpongeBob knows the Krabby Patty recipe. So I can, eat a Krabby Patty from SpongeBob and know that he has the real recipe without looking at that recipe. Like magic. Wallet backups. This is what we're all here to talk about.
Can we wait 1 second?
Yeah.
But what if SpongeBob presents you a Krabby Patty that someone else made?
Uh-huh.
That doesn't prove that he has a recipe.
Well, yeah, assuming that SpongeBob made the Krabby Patty.
So if you're watching end-to-end
Yeah.
SpongeBob in the kitchen, and what you have is a Krabby Patty, you can,
Yeah, but I could also steal your wallet, and that's the same question, right? I could steal your wallet, and then I could make a signature with it. So it proves that I'm in possession, or at least of this proof. I guess that's different. I could just steal your signature, right, and give it to somebody. In which case, we still call it a zero knowledge proof, because.
So it doesn't stop you from having forged risk. You can still.
Right, it doesn't stop the problem. It's not identifying someone. You're giving a proof to something. I guess you're not proving that you have it currently. You're proving that you've used it in the past, or somebody has used it in the past, right? In the Bitcoin world, we kind of assume the opposite of not your keys, not your coins. We assume if it's your keys, then it's your coins. But keys aren't tied to an identity. Keys can be stolen. Signatures can be stolen. The proofs of that you have a key can be stolen, right? So yeah, there's people problems that technology can't handle. Right. A blockchain only kind of deals with what it can get digitally without identifying individuals. So yeah, wallet backups. Does anyone know how to back up their wallets in Bitcoin Core or otherwise in other apps? Can anyone tell me? Prem.
I mean, you press a few buttons in the wallet and then it displays. Usually it's your seed, right?
Right, yeah. And in apps, it shows you a seed phrase, right? Where it's 12 or 24 words that you have to go and write down and keep secret.
Actually, do copy and paste it.
On an offline computer, yeah, from one text file to another, I guess. But yeah, the seed phrase is what you keep secret. You could save it to some seed file. A seed phrase is a little bit different from the actual seed that it generates, but you could always generate a seed from a seed phrase and then keys from that seed. And that uses something called HD wallets, which we'll get into later. But yeah, you could also just save a private key corresponding to a public key that's used to make an address. But yeah, the most popular way I would say is the seed phrase. So I gave a definition anyway. What is a wallet backup? It's any piece of data that allows you to spend from a previously generated set of addresses. All right, so if someone can send you Bitcoin and there's a way for you to spend that Bitcoin from your wallet, then typically what we refer to as a wallet backup is a way for you to extract data from the program that can spend your Bitcoin, such that you could import that data later on and still be able to spend that Bitcoin from a different application or a different computer and so on and so forth. And so I'm going to go into a little bit about how Bitcoin Core has their wallet backups, which is a little bit different from how apps do it, wallet apps, because they use seed phrases. Bitcoin Core does not use seed phrases. So yeah, has anyone tried to back up their wallet in Bitcoin Core before? No?
I think it gives you a file, right?
It does give you a file, yes. Yeah. There's some RPCs for getting your wallet out of Bitcoin Core, and we will go into that as well. So I got this from the original Satoshi source code of Bitcoin. This is what they did to back up your wallet. So this essentially just writes your private key, associated with this identifier to a file that was formatted by BerkeleyDB called wallet.dat. So if you've ever run Bitcoin Core and looked in your directory, for your data directory, you will see a wallet.dat somewhere in there, because you could still to this day just copy that and paste it over to some other Bitcoin. And I think the original Bitcoin source code's wallet.dat is still understandable to the modern version of Bitcoin Core, although I can't confirm that with 100%. But
Wallet.dat.
Yeah.
They would only have a set of keys.
Uh,
Be able to restore.
yeah, back then it was just keys, and I'll get into the changing wallet format, but it's still wallet.dat, the same file name, but the things that you store in it have evolved over time. Yeah, and then I had wallet.dat, which I was supposed to say, yeah, this is the file that it stores it in. Huh?
Nice lead-in.
Yes, exactly. It was a nice lead-in just to this. And the wallet.dat, again, it's in your data directory, and the data directory is where Bitcoin stores its data. That directory is different for every operating system, but the default directory is like going to be the same. So if I'm running between operating systems, if I'm running Mac in Bitcoin Core, and then Roz running Bitcoin Core on his Mac, then we will have the same data directory default, which wallet.dat will be in. Okay, so I do get into the original wallet.dat here. This file wasn't encrypted by default, and a new key would be saved to the wallet.dat every time a new receive address was generated. So behind every receive address, there's some private key, public key pair, which I call this key pair. And back then, BerkeleyDB was the only supported database, if that rings a bell to you. But BerkeleyDB is a piece of software that was formatting the data that goes in your wallet.dat file. And yeah, this is how it looked. So yeah, the more receive addresses you made, the bigger this wallet.dat file would be. It's not a huge deal because you don't need a lot of data to store a private key. So even if you had 1,000 private keys, it's still not going to be huge. But it generally is less to try and, it's generally better to try and use less data if you can, because you have less to keep secret. And you can transcribe it in different ways, of course. Like you've seen the border wallets and other schemes people use to try and encode their wallet information on paper so they don't have to touch a computer. And yeah, because it wasn't also encrypted by default, people used to run encrypted drives and move their wallet.dat file there. And yeah, just have it, as a hot wallet, be unencrypted. So, as I was mentioning before, you kind of have the burden of multiple keys every single time you make a receive address. You have a new key pair, and you're going to start accruing all these private keys into that one file. Again, not the biggest issue, but again, the less data you have to store, typically the better, because the more ways you could figure out how you want to store that data. So one of the innovations that they made is HT wallets. So before reading too much into this, anyone have the basic idea of what an HT wallet is?
Well, I attended that session of UBS. So
Yeah.
yes.
Yeah. Can you give me a brief description of the most abstract or high level?
Hierarchical deterministic wallets have a particular algorithm they use for generating seeds in sequence.
Yeah. So you get different keys. Yeah. You could generate.
Keys in sequence. And
Yeah.
there's an order to them, right? So if you do it once, it'll give you one key. If you do it twice, it'll give you another key. And
Right.
you keep doing it. And so, when was this implemented, more or less?
I don't know the year, although I know. Well, when the BIP was introduced is different from when this.
Implemented.
Yeah, it was when it was implemented, or even when someone first discussed the idea. I think in this one, it was there was some Bitcoin Talk post about this. So I have no idea the exact time it was conceived or who conceived it.
2014.
Yeah, the BIP is the easiest way just to get a ballpark estimate of the date that this was conceived. But yes, Prem said it's a scheme for generating multiple keys or key pairs from one seed. And this is really cool because the seed is first used to generate something called a master extended private key, from which many key pairs can be derived from. So your seed is not a key in itself, but you could generate a key using the seed. Extended keys are private keys or public keys that are appended with an extra 256 bits solely used in the process of making new child keys. So without knowing the parent. Because of the algorithm this uses, you actually get like this string of bytes, and the left part of the bytes is used as a key, and then the right part is used to derive more keys with. So when it's extended.
How many more keys? 10, 20, 100?
There's a lot of keys. I can't remember 2 to the something. You know, more keys than you'll ever know what to do with from one seed. So extended keys, yeah. So I kind of went over that. And then this is kind of a small detail, but the first 4 bytes of the hash 160 key hash is what we refer to as the fingerprint, of a certain key in a certain path. And some good way to kind of think of this is like, regular functions might take 2 values like x and y and return the sum of those values, x plus y. So, f of 1 and 2 are 3. So think of HD wallet scheme having an algorithm that can take something like a seed and a path and then generate a new key pair. So in this example,
Interesting.
yeah, in this example you take a seed and then you could take some path. I meant to put like an empty path here, so I forgot one of the quotes. And then you get a new private and public key pair here. So just imagine you can keep changing this path and using the same seed and get multiple different keys from it, which is very useful because that seed is now a lot less data that you need, and you could store it again in ways that you couldn't store big blobs of private keys. And I also wanted to say, this takes in a path, and one time it was mentioned that you can only search through a limited amount of paths. You don't actually look through all the keys that the seed can generate when you import a seed into a wallet. Yeah.
Called the gap limit.
Okay, yes, the gap limit. So the space is way too big to look for every single key pair and address that could be generated with the seed. So you actually limit it. And different wallets can implement different things, but typically, it's like 100 or something like that.
I think it's either 50 or 100 is like what they do for, and if they find out.
Oh, right, yeah. Okay, yeah, and all right, yeah. If they find one, then you might increase that limit a little bit more. Is what you're saying, right? Yeah. So you're not searching too much through this space because you shouldn't really get into the state where you're using a derivation path that is like a super high, like not number, but like path, because paths actually instruct the algorithm on like how to construct it. But the path isn't a number; it's typically denoted with like 0/1/0, something like that. And modern wallet. So before I showed you how the old wallet looked like, and modern wallets are a little bit different. So they come in 2 flavors. You have legacy wallets and descriptor wallets. Descriptor wallets are what today's default is, and it uses SQLite as opposed to Berkeley DB, which is pretty cool. SQLite is a well-known technology and is a lot easier for some to use than Berkeley DB. So both wallet types default to being HD wallets on creation, whether it's legacy or descriptor. And really old wallets can be converted to an HD wallet using the upgrade wallet RPC. And I included some of, if you've used Bitcoin Core before and you want to make a wallet, you actually make a RPC call to create wallet, and you give it a name, wallet name. But if you look at kind of what the defaults are, if you don't specify so these arguments, you'll see that descriptor wallet is just defaulted to being true.
I remember when you made that change. Ion broke.
Something broke?
Ion, the DID identity.
Okay, yeah.
Because it used just the old kind.
Yeah.
Not a descriptor wallet, and so if you start up a new node, they just didn't have this path, so it just broke.
Yeah. Well, yeah. that does suck. When you make changes like this to like wallet formats, there's always the risk of something going wrong, and then if you load up the wallet.dat in the new Bitcoin Core, maybe it won't find the Bitcoin that you're supposed to have, which can be a little bit scary. But yeah, I mean, it typically doesn't delete your your keys because you're importing from somewhere else, or people back it up. But it might lie to you about how much Bitcoin you have just because it can't comprehend these changes in formats. Okay. All right. Just wanted to check, see if anyone had anything in the chat, but no. Exporting keys. So you don't have to just back up the wallet. You could also just export some keys. So Bitcoin Core also supports exporting keys using the dump priv key, RPC, or the dump wallet, RPC, or the backup wallet, RPC. So all these aren't actually exporting keys. Some export more. So dump private key does give you a private key, but dump wallet, that should give you things like the seed that your HD wallet was made from. And then the backup wallet just kind of copies your wallet.dat to some specified directory. But again, the wallet.dat should have everything you need to actually spin up your wallet in a different Bitcoin Core node, in a new computer, whatever else that you may need. And then there's something else called WIF, and which is like, does anyone know what WIF is?
Wallet import format.
Yes, wallet import format. It's a pretty cool thing that was made. So maybe to understand as we lead into what a WIF is, when storing a private key, what information do you think should be stored with it? So let's say the assumption is that you only use one address corresponding with your public key, and you make pay to public key hash addresses all the time. I guess this is not a great way to phrase the question, but there's certain things you can add in with your private key that make it better, when trying to read it back in. Or some things are necessary, right? Like the network. And I'll just go to the next slide. But yeah, I didn't feel like writing this, and I saw River had a good explanation of it. But on the left, I have my explanation. On the right is River's nice explanation. And you can scan all these QR codes, by the way. They lead to the references that I put in here. But raw private keys that Bitcoin exports are usually put into WIF format, which is wallet import format, as was stated. And it contains information about the network. So whether you're on Signet, testnet, mainnet, and two checksums. So there's a checksum that you put into the actual WIF format before the base 58 encoding. So base 58 is the type of encoding that I've gone into before. It's how addresses are encoded. And part of base 58, the encoding requires a checksum. But before that, there's another checksum just for the private key. Then checksums are values that you put in that make sure that you don't corrupt the other values. So if I gave you a sequence of numbers 1, 4, 6, I could give you the sum of those numbers as the fourth number. And when you get the numbers, whenever I give you 4 numbers, you always add up the first 3 and make sure they add up to the last 4th digit. That's kind of a bad checksum because you get a lot of collisions. If you shift around those numbers, then you'd get the same sum. But there's better checksums that are made, and these actually use better checksums than just a straight sum of numbers. And anything River says that's interesting here? Yeah, raw private keys are large numbers. They're great. Just like how I said, they're represented as bytes. WIF format adds a prefix byte, and it has different things for mainnet. Oh, so this is kind of interesting. When you put something in WIF format, you prefix it with a byte that represents the network that the private key is for, whether it's for testnet or for mainnet. So if you have a private key in WIF format, you could actually see if it's for mainnet or testnet just by looking at the characters it's been base 58 encoded with. So if it begins with a 5 or a K, it's on mainnet. Yeah, all Bitcoin private keys begin with 5 or a K. Next, 1 byte is added to the end of the private key if it's blah, blah. All right, public key should be used. This compressed format's not super important here. you do some SHA-256 checksum appended to the byte encoded private key, and then you do another conversion of that to base 58, which again has its own checksum included in its format. So there's some other wallet backup schemes which we did talk about a little bit. Most notably, one that is probably ubiquitous with any Bitcoin wallet or like crypto wallet in general that is not included in Bitcoin Core that we were mentioning before, which are seed phrases. So these, what I could find on the web is that seed phrases were made by Electrum as a way to easily back up one seed, and it turns out picking 12 or 24 random words from a defined dictionary can provide enough entropy for an algorithm to convert those words to a seed. And seed phrases should not be chosen arbitrarily and is best generated via an algorithm. So you can have a seed phrase, usually it's generated by a wallet, and you see those when you open a wallet. That seed phrase, according to some specification, is converted to your seed. That seed is used to make a master private key, and then the master private key is used to make a whole bunch of child keys, which then have more child keys.
Maybe I'm nitpicking, but does arbitrary not include randomly?
Does arbitrary not include? Yes. In this context, I was trying to say, like, if you wanted to choose it just from looking at the list, you probably should.
Yeah, but like I've seen at Seed Signer, actually, they sell this thing where they got all the words and you can like put it in a
hat, yeah.
A hat and shake it up, and then you can pick them out. I think that's a little bit better.
Yeah, it could be, like unless someone finds out something like patterns, right? Like maybe every single time someone prints out the words and they cut them, they put them in a stack. And usually when you put them in a stack and you put them into a hat, depending on how you put it, most people might do it in a certain way, and there's actually some probability distribution which shows the keys aren't fully random, right? Like, yeah.
More ink on one makes it spin more.
Huh?
One more ink on makes it
Right. Yeah, exactly. Yeah, it's like, oh yeah, these words will go to the bottom because it took more ink to print it and it's a little bit heavier. Yeah, things like that, right? That's a good pattern to see. And then I have a note about this. I use the word random here. And in reality, I said randomness is a moving target, and it's limited by our knowledge of currently unknowable things, or an absence of a predictable pattern. So that's kind of what we consider random as a concept, things that are unknowable.
Fun fact, do you
Yeah.
guys know what Cloudflare uses to derive randomness?
Yeah, the lava lamps.
Yes.
Yeah.
They have all the lava lamps, and the camera looks at them, and
Like
that's how
computer
they
vision
Yeah, and it's cool because they're like, yeah, even if someone walks in front of the camera or whatever, that's even
It's a
more
part
of
of
a
the
randomness.
Right.
So it's a pretty interesting way to derive randomness.
Yeah, it's unknowable, anything that you could start deriving patterns from kind of no longer becomes random. So it's,
A lava lamp is kind of like a flaring cloud. Lava lamp.
yeah, and it works, and they are not chosen arbitrarily. And again, chosen arbitrarily means a person picking out their words. In computer science, we call numbers made up by a computer pseudo-random numbers because we know the mechanics of the functions that create randomness, but we parameterize it with like secret information. And that's like kind of good enough for us. Like, you can generate random numbers using time as a seed. And that's what early algorithms used to use. But when randomness becomes a core part of your application, like if it's protecting your money, then you kind of want to make better sources of randomness that are better than time. And we've seen that it's very hard to do, and if you do it wrong, you get catastrophic effects. Yeah. Does anyone have a recent example, maybe regarding a certain book about a failure to provide sufficient randomness? Yeah.
What's his name? Eric.
Yeah. Exactly. Yeah.
Yeah.
Milkside, I think what the vulnerability was called. They didn't have enough randomness, and people were able to enumerate I think they're using time as a seed, and they were able to enumerate probable times and actually found a good amount of Bitcoin that was secured using
What was this?
Milksad. I think that was what the vulnerability
So
was.
to be fair,
Yeah. Here, I can put it out.
He mentioned that like that was just like he should have named the function something different, but it wasn't supposed to be a
Here we
function
go.
that people actually use. It's supposed to be a pseudo-random thing just for testing purposes and whatnot. That's what he said.
Milk sad.
Yeah. The issue of an insecure Bitcoin command called bxseed in the libbitcoin library has made it vulnerable to attacks, potentially allowing adversaries to guess private keys and access Bitcoin funds. Insecure command only produces 32-bit random seeds, significantly reducing the number of possible seeds, blah, blah. But yeah, people essentially were looking at this algorithm and were able to enumerate some private keys because there was a pattern with how these private keys were generated such that it didn't actually allow a big search space. And you had a good chance of getting money. But they disclosed this responsibly, and I don't think anyone's money was stolen from this. But I could be wrong. Yeah, and it made it into Hacker News. That's kind of cool. Yeah, so pick things that are random. And I have a cool exercise. To show why you probably shouldn't pick a seed, try your hand at adversarial randomness. So I say adversarial randomness because sometimes when you actively go out of your way to choose something that's random, you could actually make something that's like, yeah, not very random. And an example of this I could actually show you. Guessing game, MIT. Where is it?
Magicians use this all the time.
Huh?
So magicians, like the like people, like they know how to make you guess things that they want you to guess.
Yeah, and like you start acting differently once you kind of know that something's up. Like, let me just scan the score because I don't have the link, but I wanted to show it.
That's not the right word.
I don't know. It's not the first of my search results. Oh, the Mind Reader game is what it's called. Mind Reader game, MIT. I'm looking at on my own screen, but I'll put it up here, and we'll have Prem play it. All right, Prem, pick left or right.
Right, 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 right.
Okay. Okay.
Don't tell me what to do. Right,
Uh-huh.
right, left, 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 right, right, left, right, right, left, left, right, left, right, right, left, left, right, left.
Wait. Yeah, I think that was it, but yeah. All right, what else? Let's see if we can beat it. You have 4 seconds or until we get to the end.
Left, left, right, left, left, right, 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 left, left, right, right, left, right, right,
Uh-huh.
left. What am I doing?
Huh? We're trying to. So every single time the bot's number goes up, it guessed what you're going to do.
Okay, left. I won.
Okay. Yeah, so you won, but it was able to guess 19 out of 25. So imagine if you're generating like bits this way.
Yeah.
It's like significantly reduces the entropy. Well, especially if you're trying to
He
think.
did really well.
Huh?
19 out of 25.
Yeah.
Because like if he had a
More than half the time.
Huh? Yeah.
Yeah.
It also works differently if you pre-plan which directions you want to go to without looking at it. Because sometimes when you see what like they're doing, it actually kind of reduces your chances. So if I did like right, left, right, left, right, left, right, left, it sometimes kind of like you get better results. Looking at this sometimes makes me want to click in certain ways, and it could start gaining on me. So it's the adversarialness of it all that sometimes allows it to get more data. But yeah, and this is a simple algorithm. So people just aren't all that good at randomness. Sometimes we follow patterns we don't even know that we follow it. So seed phase criticisms, I wanted to go into this a little bit. Electrum, as the people who are stated to have the first seed phrase, they have some criticism for the BIP, and one of them is that it requires a fixed word list. So it kind of does and kind of doesn't. It's kind of weird. You could, so those 12 words that you pick from, theoretically, you could choose like all these different kinds of like words in different dictionaries, but as part of the spec, there's a checksum that's calculated, and the checksum does use a dictionary. So it's like if you left out the checksum, and you don't follow the spec, then you can use whatever words you want. But if you include the checksum, you have to use the dictionary words. And the spec is just kind of written weirdly, and Electrum has harsh words for it because again they implemented it. They say 2 years before the BIP actually came out. And another thing is there's no versioning for your like the seed phrase, which is kind of annoying because like let's say you want to change your dictionary or expand it or have include different languages. You know, even as an American, maybe I want Chinese words, even though I can't write them down. But maybe Chinese, maybe Russian words is a better thing.
Cyrillic is also not kind of easy to write.
Spanish, you know, some Spanish words, and people do it anyway because they just don't follow the spec. Electrum has their own spec entirely, which is completely different from it. Let's see if I can find the Electrums, and you can see their straight criticism of this. But yeah, people in the Bitcoin space are very opinionated, and it seems Electrum is as well. And I just kind of copied, you know, summaries of this, but here's them criticizing the fixed word list, and here's them also criticizing the version number. And they have their own thing where they do include a version number, and they don't have a dictionary that you could use, so you could use whatever words you want. See, from a hash to the normalized seed phrase with no dependency on a fixed word list. See, Electrum going global. See, those are some drawbacks with seed phrases. So it's, you know, maybe a better spec will come out soon, or V2. And so something else that seed phrases don't quite give you completely is the need for more expressive backups. And what does that mean? It's like, what else do you need sometimes when you spend Bitcoin? Or like, what is it actually locked by? Or what can it be locked by? Like a script, I've kind of mentioned, right, script before. And you can make your scripts pretty arbitrary. I could say, give me a value that, you know, sums up to 2, or give me 2 values that sums up to 2. And all you have to do is add, 1 and 1. So
as soon as you do that, a bot is already looking at this.
Yeah.
It'll steal that.
Yeah, they are looking for things like that. I mean, you can put some randomness in it. You could do some push datas, because there's a witness hash is all you have to look out for. Miners have a better chance of stealing it after you spend, but you'd have to have a very intelligent miner to know that they could, you know, steal it, especially with all the different variants you have of these scripts. So yeah, the seed phrase is not sufficient for all Bitcoin use cases. I think that's like the main thing that I wanted to get by. And yeah, another problem with just having a seed phrase is you might have a weird derivation path. There are some standard paths that you put in to that function to generate keys from your seed. So it's like before you use this path, you use these paths. But you don't have to follow those. People could put whatever random path they want, and a wallet dev might not respect standard paths for who knows why, right? Maybe they have opinionated reasons like Electrum did for not having the seed phrases that are in the BIPs.
That's what Satoshi would want.
Right. Yeah, chaos, everyone doing their own thing. And it's fine for people doing their own thing as well. It's just good if it's standardized sometimes. And, you know, an example of a script that you'd want to do is a multi-sig. You know, let's say Jerry and I are in a 2 of 2. He has some private keys, I have some private keys. And to spend, it requires both of our signatures. You have to, put that as a script in Bitcoin, an expression that you have to give a value to. It's a program that's locking a Bitcoin that requires a specific input that can validate. Lightning also uses a script that is non-standard. Did you have any question or no? Okay. So, the next thing that we have to look at, because we have things like scripts, are wallet scheme considerations. So why might we want more wallet schemes? because, or why might we want like a wallet scheme that is standardized over seed phrases and raw private keys? And we might want something that's standardized because we might have more data to store with our seed phrase. Again, if you use complex scripts, you need extra information to be able to spend your Bitcoin. And you also want standardized wallets so you don't have potentially intransferable wallets. Right? You always want wallets to be transferred between each other. You don't want vendor lock-in, especially with something as important as your private keys. And some things that people have worked on to try and make these backup schemes more expressive than just having a private key is having something called wallet descriptors.
Could you go back to the previous slide real quick? So
Yeah.
I think Samurai used 24 word seed phrase. Like, I don't think this is exactly what you're talking about here, but like, is that kind of an example of intransferability if like you were trying to transfer to
Yeah.
a wallet that used a 12?
Yeah,
seed?
exactly.
Okay.
Yeah, so standards like that, you might want to have something that is always transferable. And to be fair, you could always convert those 24 words into the actual seed, but I also don't know how many wallets will like let you put in hex
Actual
seed.
seed.
Yeah, like 0x, 05, blah blah. So yes, that's a perfect example of intransferable wallets. So standardizing might seem like I don't know, centralization of planning or something, but it actually encourages more decentralization because you could, move over your data from one place to the next. Yeah, so wallet descriptors is a scheme another scheme that you use to back up your wallet, and it allows you to put more data than just a seed or a private key. I have a little description of programming language. I say programming, but kind of it tells your wallet to do something, I guess. So used to make certain Bitcoin scripts easier to write. And then I kind of copied this from the BIP, and you could, again, scan this QR code if you want to see the BIP. But it allows you to have a little bit more information in your backup files. So I could put PK here and put a key expression, or PKH and put a key expression. And this is for you need this the private key for this public key in here to spend this script. And when you have PKH, you're like, oh, this is actually locked in a script that is looking for your public key hash. So these prefixes are associated with standard scripts or standard programs that lock your UTXOs. And when you put a key here and you import a file with these wallet descriptors in it, then your wallet can now search certain types of scripts that are generated, according to these prefixes and the values inside. You could also put raw scripts like this, sh. So this is pay to script hash type of address. And you could put in a script in here. And if you just had this in your wallet file, when you read it from Bitcoin Core, then it would know, okay, we should probably track the address associated with this pay to script hash descriptor, and we can tell him how much money he has in it. It may not be able to spend, which is a problem with this descriptor format. If you just put a script in here and you wrap it with sh, then you can tell your wallet, hey, I have some Bitcoin locked with this script, but it doesn't really say how to spend from that script. Witness public key hash, you have all these different types of output types. Multi for multi-sig, you have sorted multi because sometimes you don't want to have to deal with trying to brute force which order the keys are in, and you forget that. Combo, raw, address, blah, blah, all these different things. And wallet descriptors. So there's some benefits over exported keys or seeds. Descriptors include derivation paths. So in those key expressions, you could actually just put there's a syntax you could put in those key expressions to specify your wallet fingerprint, which is, again, this first, I think, 6 bytes of the hash of public key. And you could also include derivation paths. And you could include your extended private key in these key expressions. Or if it's a wash-only wallet, you could just have the public key here. Yeah, so you have the address type specified. Descriptors can indicate one of the keys is used in a multi-sig. So my wallet could have multi blah blah, and one of these are like my keys, and the rest are other people's keys. But importing this into my Bitcoin Core wallet will let my Bitcoin Core wallet know to track the UTXOs that's associated with the address of this, even if I can't spend it unilaterally. Miniscript. So miniscript kind of takes this idea of descriptors to the next level. It's, again, I kind of call it a programming language used to make Bitcoin script easier to write and reason about. It's like descriptors on steroids, I would say. So with descriptors, you couldn't write like any script you wanted. You could encode a script in a descriptor such that the wallet could derive an address from it. But you couldn't like write script. Like the script that you put into a descriptor is bytes. Miniscript kind of has a human readable language that can be converted to a script that is, to bytes instead. So there's this higher level language that you could write script in, and a higher level language that you could export your script in, such that, I could read this and kind of see what it's trying to say. So this expression, for example, says I need signatures for two public keys. I need a signature for A, and I need a signature for B. And the V, this V colon right here, says, hey, run op verify after you run check sig on this signature for A. Again, you don't have to know too much about like the details of this, but just know that you could write scripts easier this way. And instead of using a descriptor format, which again, this is just useful for giving you an address, this is useful for like writing your script in. So instead of having this script in this SH, now you could put this, which is human readable, instead of like 00 or whatever sequence of bytes that you want. That is the big innovation here. I mean, there's more innovations, but it's just from the surface level. That is the innovation here, if you understand nothing else. Miniscript in the context of backups. So miniscript standardizes a way to represent arbitrary scripts. Not completely arbitrary, because you can't make like, you can't write all the scripts that you're able to with like Bitcoin script. It's a subset, but it's a subset, it's the only subset you'll need, essentially. The things that miniscript doesn't cover are typically not really worth doing to protect your money with. So you could write most scripts that you'd be able to do with raw script using miniscript. So it standardizes a way to represent arbitrary scripts, and it supports wallet descriptors in the place of keys, which is also kind of cool. It also makes fulfilling scripts easier, since there's a wallet functionality in Bitcoin Core that knows how to satisfy a composition of expressions. So if I imported this into Bitcoin Core, and in like these A's, let's say I had some wallet descriptors of like private keys, then Bitcoin Core would know to like pick up these private keys. And if I wanted to spend this, Bitcoin Core actually has a way of looking at these expressions and giving me what we call a satisfaction for this expression, and saying, okay, since you had in these like A and B's, you have private keys for these, we'd actually generate signatures that will help fulfill a script that was made using this miniscript expression. So basically it allows you to make addresses that contain more logic in them and have it be easily spendable by Bitcoin Core and by any other wallet. So it's building blocks essentially to make it easier to have more complex spending policies. Again, that's the best high-level description I can make. Miniscript wallet backup templates. So wallets aren't just made for exporting, but also importing into Bitcoin Core. And miniscript doesn't only allow you to export addresses derived from miniscript expressions of complex scripts. It allows you to import expressions as well. So why might this be useful to import a miniscript expression? Anyone have I kind of have it here anyway. Yeah, it's cool to import miniscript expressions, because now you can have third party. Remember, miniscript expressions allow you to have more complex spending policies, locking your UTXO, locking your money, and when you are able to import these more complex policies, you could actually have third-party applications start generating policies for you. Again, they can enable complex policies like decaying multisigs, which is a scheme that's like, it's a 2 of 2 between me and Jerry, but after a year, I can spend it without Jerry. So that's an example of maybe a more complex script that you couldn't actually tell Bitcoin Core about. Like, it wouldn't understand how to spend it after a year, or even like within a year. Whereas with miniscript, you can give this like expression to Bitcoin Core, and it now understands how to spend a decaying multisig whenever you need to spend it.
So decaying multisig, does that mean like it's becoming, what is a decaying multisig?
It decays, yeah. Yeah, exactly. The number of signatures over time.
Okay, so over time, it starts as a 5 of 7, becomes a 3 of 4, something like that?
It's whatever
you specify.
Yeah.
you specify in the locking script.
Okay, so the script defines how it decays, and this.
Yeah, well, you could write that all in miniscript. And here, I can even show you an example of how decaying multisig works. I think Bitcoin miniscript, hopefully they have it here. If it's not, it's in the other thing in the next slide. But 2 scripts, he has a whole bunch of these policies. User, a 3 of 3, here we go. So, this isn't like the easiest to read, I guess, but this is what a decaying multisig one of the policies would be. So, hey, like we need 3 of these things to spend this UTXO. You either get a signature from key 1, key 2, key 3, or older, and this represents 90 days. So if you can if you can meet 3 of these conditions, you could spend it. So, obviously when you first make a UTXO locked by the script, it's not going to be after 90 days, so you won't be able to spend it, and you have to only fulfill these conditions, so those have to be your 3. But after 90 days, now you could say like, hey, I have a free condition, and this essentially makes this 2, because this is unconditionally fulfilled after 90 days. Now I only need 2 more conditions, like key 2 and key 3 signature, or key 1 and key 2, so on and so forth. Yeah, and then you can make more complex schemes like this. So again, it could be like 7 out of 7, and then after like 2 out of 3 or something. But yeah, decaying typically means you need less signatures over time. And this is useful if like, a lot of people are starting to do multi-sigs with like a service provider. So like maybe someone like Block will offer a service where you can't spend your keys with only your device. They need to sign off on your transactions. Well, they do this so they could do 2-factor authentication for your wallet. So now if you're using something, let's say a Block wallet, and you're trying to make a transaction, the wallet will send it to Block servers first. And let's say it's above a certain threshold, Block will say, hey, you need to do 2FA. We're going to send you an email before we sign this. They send you an email, you approve it, and then they finally broadcast the transaction with their signature. That's how Green works today, actually. But Green does not use miniscript, and that like limits them in a lot of ways. For example, the transferability problem that I was explaining before. There's some issues with how wallets were in the past. For example, some know there's an instance where I was using Green and I needed to RBF something and I couldn't. But because it's not transferable to other wallets, I'm kind of stuck with Green's functionality. Whereas if I was using another wallet, I would actually be able to import the seed somewhere and RBF any transaction that I need to. So again, standardizing.
Transactions look different. They're like 5 or 7 signatures.
Yeah.
They're gonna have individual.
In the witness, it's
in the witness.
Yeah. You would have for the signatures that satisfy a script like this, you'd have it in the witness.
It would be more expensive as you get more complicated policy.
Exactly. Yeah. Well. Yeah. The bigger like the scripts that these compile to, you do have to pay for the size of those, and depending on the witness that it requires to fulfill those scripts, you have to pay for those as well. Yeah. And you have all these different policies that you could have, but it's hard to make secure policies, which is kind of what I have here. Let me move this out the way. So just like any programming language, miniscript policies can be written incorrectly. So luckily, miniscript compilers, definitely a weird logic thing, no apostrophe here. Luckily, miniscript compilers have the ability to analyze certain script properties to tell you things like whether the script is unspendable or is anyone can spend, but there can still be logic errors. So miniscript, like the compilers that are out right now, have some cool functionality. Like if you do something really stupid, and let's say you made a miniscript policy where anyone could spend it, then miniscript compilers today will tell you like, hey, like this is stupid. Or like,
It won't say that.
well, instead, yeah, it'll say this is insane.
That's what the
Yeah,
program
so yeah, there's a syntax like in miniscript that you'll see. Let's see if I can find it, but I think that would be funnier. Because when I first saw it, I didn't really understand like the is sane and is insane kind of stuff.
Sanity checks.
Yeah, it's like exactly sanity checks of like what your intention might be when you make something a miniscript policy. Why can I move this window over? It's like bonked a little bit. Oh, my Visual Studio Code does not want to move over. Let's see if I do it this way. There we go. Yeah, so you have things like is sane sub-expression, and you want to make sure that things are not insane. So, and it checks certain things that I won't get into all the way, but it makes sure like you have a sane mixing of time locks. Usually you don't want duplicate keys, so it's like, hey, this is probably not what you want, because if you have a multi-sig with like of two, and it's Jerry and Jerry, then that's probably not what he wants, because he's just going to spend more money when he spends that Bitcoin, because he's going to need two signatures for himself. You know?
Jerry's trying to hide money from himself.
Yeah. Yeah, and everyone else can see that it's just him and him. It's the same exact key. Time locks mix, you want to check if it's not malleable. I think in the last Understanding Bitcoin's course, I spoke about malleability a little bit. It allows you to change the transaction ID while still having the same like information for the most part. So you can like trick somebody. You could broadcast something and say that like it didn't go through, or I don't know, all these things. Is valid top level. Yeah. So anyway, these are the sanity checks, and these are kind of interesting. What are you looking for?
Anyone has an iPhone charger?
No.
We're Android people.
Yeah. No,
Randy has an iPhone.
yeah, I do have an iPhone, but I don't have a charger. Yeah, miniscript policies can be written incorrectly. So to combat this, they actually made a whole repo called miniscript templates, and their goal is to teach people how to write miniscript correctly. You know, and
Can you send me that?
these templates. It's kind of an empty repo at the moment, though, but it does have a pull request, and it is maintained by Blockstream. And if you look here, issues, there's another Randy, I think, who works on these things.
Not currently.
No, not see Randy McMillan. I've seen his code a lot.
I thought it was you doing all those.
No, unfortunately, yeah, no, I'm not that Randy. But yeah, people are making issues, they're making pull requests, and the whole goal of this project, Miniscript Templates, is to try and come to some like standardized ways of doing certain things. Like, why isn't this in a nice format? I'm trying to. You could view it as Markdown. I just don't know why it's not. I forget how to do this. It seems. Oh, this is YML. That's why. See, there's some good comments here, and if you look at this README, which hasn't been fully committed yet, it kind of states the objectives of it. So they call these miniscript templates Mint, and you'll provide some common miniscript policies, so that again we could standardize the way that we write miniscript policies, not for interoperability, but just for safety. Because we don't want people writing dumb policies that lose people money, right? Each mint will be provided as is, blah, blah, and you have all these, the first specification. So this is how you should probably use time locks. I forget one is, this is how you should use the degrading or decaying multisig. I prefer decaying here. I might comment. A nit, of course, which means like, hey, you can ignore this. 5 key degrading multisig. And yeah, feel free to go and review these and leave comments. It's still in the beginning phases. I mean, I already see there's a good amount of comments here. But yeah, there are initiatives to try and make all this easier for people and for companies, and even like federations, like Fedimint. Maybe they want to store some on-chain Bitcoin in a nice decaying multisig with a federation. That's made by miniscript, because you could use a template that's off the shelf and made by a third-party program and still import it into Bitcoin Core.
Time chain foundation.
Huh?
Does Liquid work with miniscript?
Yeah. So miniscript. Liquid has its own version of miniscript. You could use everything in Bitcoin miniscript in Liquid and more, because Liquid has more opcodes. You could use covenants in Liquid. So there's a project called Elements miniscript, which actually allows you to write miniscripts with covenants, or like this kind of smartish contract functionality. So you could actually write more expressive miniscripts in Liquid, or for Liquid, using the Elements opcodes.
Is Liquid turned into Ethereum?
No. Many things, that prevent that from happening. Yeah, even in like execution environment, Bitcoin just does things a lot differently. But this is my last slide anyway. So I wanted to give some last words on backups and security, that it doesn't end at securing your backups. For sure, if you ever run Bitcoin Core or have any wall application ever, you should probably back up your seed phrase. Different ways you could do it, whether it's on an offline device, in an encrypted file, or on paper, or some people get it like engraved inside of like a safe, or you can put it on a metal plate and put the metal plate in the safe. There's all these crazy schemes that I've heard people doing. Some people get the seed and figure out their own scheme for encoding it, maybe in their house, somehow. But yeah, just because you back it up doesn't mean it's always secure. So always look to keep your seeds and private keys secure after backing up. And make sure you don't use, or it's probably not a good idea to use an off-the-shelf scheme that you come up with. Use something that someone else has used.
Or that Luke Dash Shear comes up with.
Right, yeah, exactly, which is a famous example. Yeah, which is not how many people held their keys.
Keep it simple, stupid.
Yeah, try not to put on any like servers or anything that could get hacked.
Well, you mentioned the drives that get encrypted.
Yeah.
That's dangerous, because I've had one go bonkers on me, an older one, and then you could unencrypt it.
Yeah, decrypt it. Yeah. Well, maybe the teaching from that is you should regularly decrypt and make sure everything's okay, or hold different encrypted copies.
Yeah.
Yeah, using different pieces of software. I saw like early on, I was looking at some Bitcoin Talk posts, and I know they use like TrueCrypt, which is software made from some other software that was made by Paul Rowe, which is kind of infamous for being like this crime lord who's also interested in cryptography. And there was this whole thing about how he might have stole that code from this other company. That was very interesting. I guess, yeah, kind of off topic. Some people might think he's Satoshi. That's why I thought it was interesting to bring him up. He's probably not. But he's a very interesting guy if you ever want to look into him. Yeah.
No, Satoshi's these 3 Japanese researchers.
Right, no one knows. I don't think he's Satoshi at all, but I do think he's interesting. There's a whole book written about him called.
Dead?
There's a couple different books. No, in prison.
Oh, okay. It's like
I don't think he made it out. Yeah.
You ever worked for the NSA?
Ooh, he's
Arrested.
former criminal cartel boss.
Yeah,
that's
what I said. Yeah, he's a crime lord.
That's a good CV right there.
Yeah.
What? That turns into software development. That's interesting.
Yeah.
He's like a genius, prodigy type guy, wasn't he?
Huh?
If I remember the story, he was like, and then he got into organized crime.
Yeah, I mean, I don't know. Who am I to say who's a genius or not? But
Maybe the Time Chain Foundation could book an interview.
yeah. Yeah, he's a decent programmer. Yeah, look, drastically changed. Compare these looks.
So he's from Zimbabwe.
Zimbabwe. They're from South
Yeah.
Africa.
Yeah.
Wow, a white man from South Africa,
Uh-huh.
crime lord, software engineer.
Yeah.
He's very interested, very colorful guy.
Yeah. Well, okay. Yeah.
Colorful guy.
Yeah. So he was born in
That's a
Zimbabwe,
movie.
but I remember he was
That's a movie.
growing up. Yeah, South Africa.
Rhodesia when he was born.
Yeah.
Rhodesia.
Well, yeah. Google does say Zimbabwe for his birth date, which I see where you got that.
Wow.
So yeah, maybe it was there. Then he grew up somewhere else, but yeah. This is the last slide anyway, so I guess I will call it a presentation.
Woo! Good job, Randy. Good job.
And this will wrap up. You know, Bitcoin, understanding Bitcoin source 11. So, you know, thanks to everyone who came. And
Any questions in the chat room?
no, I'm looking at it now. You know.
So when are you gonna like make a little website for this so that you can upload all these presentations so people can review them later?
I don't know.
You should definitely do that.
Yeah, I mean, Roz was telling me I could put them on Bitcoin.tv, I think it was.
Bitcoin TV is
Well, the videos, yeah.
Yeah.
Sure.
They won't like delist and like rug you like YouTube money.
Well, I don't know. Who they still might.
Hopefully not. At least they're a friendly.
Yeah, I mean, feel free to download, you know, my videos too, just like some people did for Bitcoin Uncensored. Yeah, just in case it's erased from the internet.
So in the course of this presentation, I had an interesting idea for a time chain foundation. Like if we could get miners to mine our transactions for free, like we could give them tax credits
Uh-huh.
for mining the transactions.
Could be.
Yeah. Like in the value of what it would have taken to get in that block, right? So like
Uh-huh.
that's
That's a donation.
Yeah.
well, like it's an inverse donation, right? Like they're providing an in-kind
A service,
donation.
okay.
Yeah. Yeah, because I'm like just trying to think of like ways, like like what other like tax
I would
avoidance
say-
schemes? What?
How would you set the value to that?
I mean, I'm gonna ask my accountant.
We are still live right now.
Huh? Yeah.
I'm not trying to break the law.
Yeah. He never said anything about breaking the law.
Legal
Yeah.
tax avoidance.
Tax evasion is illegal. Tax avoidance is
Yeah,
very
legal.
legal. It's,
Yes,
it's
yeah,
your
exactly.
fiduciary responsibility.
That's true.
Yes, I do tax avoidance. I also wanted to plug. I think I'll have Understanding Bitcoin source during the week of the Vortex, and that's in 2 weeks, right?
Yeah.
So yeah, I'll definitely have Understanding Bitcoin source.
If you have not got your Bitcoin Day in Miami ticket, god damn it, buy it
Yeah.
already.
Oh, yeah.
Love Mom is for $75 off. Love Mom.
I don't
It's
know.
on
I don't
May
think
11.
Prem has updated.
I really need to update, but the problem is like I'm not
Usually it's on the
this
BitcoinVortex.com.
signer, you know?
Where do you have information about the new Bitcoin Vortex? Are you gonna update this?
I need to, but like, look, we gotta like it's for Halloween. Like, I need a new banner graphic.
Yeah.
And,
You need to tell people somehow about the new events.
Yeah.
Keep an eye out for the Bitcoin Vortex.
hopefully this weekend I can update that.
Yeah, on the BitcoinVortex.com. Maybe we'll have
But
some.
the events will be listed on BitcoinDay.io.
Okay, so
They're
yeah,
gonna have a tab for it. I don't know if they have it yet, but they will have it.
BitcoinDay.io.
Miami,
Maybe not
Florida.
yet.
Let's see what.
No,
so I
yeah,
will.
speak yes.
I'm gonna get it in there.
Yeah, so just keep an eye out for the Bitcoin Vortex. All events are typically free. I don't know if you include Bitcoin Day as part of the Bitcoin Vortex.
It's kind of like the eye of the vortex, so that's not free.
Okay, well, the rest of the Bitcoin Vortex events are typically free unless there's something that requires funding, like a dinner. So,
Well, you can sit with us.
yeah, exactly. You could sit for free, but if we're buying something, then you spend some money. So, yeah, anyone who's watching
We're not still
live,
live, are we?
yeah, we are.
Oh.
That's why I'm saying all this.
Right.
Yeah, so anyone who's still watching live or who's gonna watch on Bitcoin.tv,
You
know,
missed this.
yeah, that there will be Bitcoin Vortex in Miami, Florida in May. So now I will be ending the stream. Thanks everyone for coming, and goodbye.